Imagine being an astronomer on the night shift. The air is still, the observatory is humming with the quiet energy of machinery, and your world is a screen of endless black, occasionally punctuated by the distant, silent fire of a star. For years, your job has been one of cataloging the familiar, of confirming the known. Then, on October 16, 2025, an image downloads that makes the hair on your arms stand up. It's from the Tidy 2M Twin Telescope, a state-of-the-art instrument designed for precision. On the screen is an object designated 3I Atlas, the third interstellar object ever detected. At first glance, it looks like a comet. It has a coma, that fuzzy, glowing halo of gas and dust that forms when a comet gets close to the sun. It's a beautiful, ethereal sight, one that astronomers have seen thousands of times. But then you see it. Something else. Something that makes you lean closer, your heart beginning to pound a little faster. Protruding from the coma is a jet, a narrow, focused plume of material. But it's pointed the wrong way. It's aimed directly, defiantly, toward the sun. This is not just unusual. It is, by every known law of physics, impossible. Let's break down why this is so fundamentally world-shattering. A comet, at its heart, is a dirty snowball, a clump of ice, dust, and rock left over from the formation of a star system. As it travels through space and gets closer to our sun, the sun's heat begins to vaporize the ice in a process called sublimation. This releases a cloud of gas and dust, creating the coma. Now the sun is not just a source of heat and light. It is a roaring furnace that constantly spews out a stream of charged particles called the solar wind. And it bombards everything in its path with radiation pressure. Think of it like a relentless, invisible hurricane blowing outward from the sun in all directions. This constant outward pressure is what gives a comet its iconic tail. It pushes the gas and dust of the coma away from the sun, creating a beautiful, glowing appendage that always, without exception, points away from our star. It doesn't matter if the comet is traveling towards the sun or away from it. The tail is like a windsock in a hurricane, always showing the direction the solar wind is blowing. This is one of the most basic, foundational principles of cometary physics. What the Tidy 2M telescope saw that night was the equivalent of standing in a hurricane and seeing a ribbon of smoke streaming directly into the wind. It was like watching a waterfall flow uphill. The image of 3I Atlas showed a 6,000-kilometer-long jet of material fighting against the immense force of the sun, aimed like a spear at the very heart of the star that should have been blasting it into oblivion. The implications were staggering. This wasn't just a weird comet. This was an object that was actively defying the fundamental forces of our solar system. The quiet hum of the observatory that night was suddenly drowned out by the thunderous sound of a paradigm shattering. The image shouldn't exist, and yet, there it was. What in the cosmos could possibly be powerful enough, or strange enough, to do that? And what did its presence in our backyard truly mean? In science, an extraordinary claim requires extraordinary evidence. And a claim as reality-bending as a comet with a sunward jet is about as extraordinary as it gets. The initial reaction from the global astronomical community was, understandably, one of deep and profound skepticism. The first assumption, the only sane assumption, was that the team at the Tidy 2M Observatory had made a mistake. The scientific process, at its best, is a relentless exercise in trying to prove yourself wrong. Before you can declare a discovery, you must exhaust every other possibility, every mundane explanation. And so began a rigorous, almost frantic, period of cross-checking and verification. The first suspect was the software. Was it a processing error? A glitch in the algorithm that stitches together the raw data from the telescope's sensors? The team ran the data again and again. They used different software, different parameters. The jet remained, a stubborn, ghostly finger pointing at the sun. Next, they considered contamination. Could a background star have coincidentally aligned perfectly with the comet, its light creating the illusion of a jet? This is a common pitfall in astronomy. The sky is a crowded place. They meticulously mapped every known star in that field of view, cross-referencing multiple astronomical catalogs. There was nothing there, nothing bright enough, nothing in the right position. The space around 3I Atlas was clean. Then came the hardware. Could it be an instrumental artifact? A flaw in the telescope's optics? A smudge on a lens? A weird reflection inside the housing? This is where the twin aspect of the Tidy 2M telescope became crucial. It has two identical telescopes working in tandem. They checked the image from the second scope. There it was again, in exactly the same place, with the same orientation and brightness. The odds of two independent instruments producing the exact same freakish artifact were infinitesimally small, but even that wasn't enough. The discovery was too important to be based on a single observatory. The team sent out an urgent encrypted alert to other major observatories around the world. The message was simple. Point your telescopes at 3I Atlas. Look for something strange. Tell us what you see. And the world looked. In the days that followed, the confirmation started trickling in, and then it became a flood. An observatory in Chile reported an anomalous structural asymmetry. A team in Hawaii noted a peculiar, collimated feature. Then came the heavyweight champion of astronomy, the Hubble Space Telescope. Its unparalleled vision, orbiting high above the distorting effects of Earth's atmosphere, was directed at the interstellar visitor. The images it sent back were undeniable. There it was, clear as day. A narrow, focused jet of material pointing at impossible angles, seemingly fighting against the solar wind. The consensus was in. The sunward plume was real. The feeling in the scientific community shifted from skepticism to a chilling sense of awe and urgency. The easy explanations were gone. The comfortable, known world of cometary physics had been fractured. They were no longer trying to disprove a faulty image. They were now faced with the terrifying and exhilarating task of explaining the impossible. The focus shifted from, "Is this real?" to, "My God, what is this thing?" It's a powerful lesson, isn't it? When faced with something that shatters our beliefs, our first instinct is to deny it, to find a flaw in the observation. But real progress, real discovery, only happens when we have the courage to accept the evidence and follow it, no matter how uncomfortable or strange the path becomes. Have you ever had a moment like that in your own life, where a piece of information came along that forced you to question a long-held belief? Just as the scientific community was grappling with the mind-bending physics of the sunward jet, a second, equally baffling mystery was emerging from a different kind of observation. While telescopes give us pictures, spectrographs give us chemical fingerprints. By analyzing the light that an object emits or reflects, scientists can determine exactly what it's made of. And the chemical makeup of 3I Atlas was, in a word, alien. When the light from the comet's coma was split into its constituent colors, a rainbow signature of its elements, the spectrographs lit up with a strong signal for nickel. This in itself wasn't entirely shocking. Nickel is a common enough element in the universe, but it's where the mystery deepened. In nature, nickel and iron are cosmic brothers. They are forged together in the hearts of dying stars, and are almost always found together in asteroids and comets. For every atom of nickel you find, you should expect to find a significantly larger amount of iron. It's a fundamental rule of cosmic chemistry. But in the coma of 3I Atlas, the iron was gone. The spectrographs showed a powerful screaming signal for nickel, but the corresponding signal for iron was barely a whisper. The abundance ratio was completely skewed, so lopsided that it had never been seen before in any natural object. It was like finding a forest full of trees but no soil. It simply didn't make sense in a natural context. Where did all the iron go? Or perhaps the more chilling question was, where did all that pure nickel come from? The puzzle didn't stop there. The James Webb Space Telescope, JWST, with its powerful infrared eyes, peered into the heart of the coma to analyze its gases. In a typical comet from our solar system, the coma is dominated by water, H2O. It's the vaporization of water ice that drives most cometary activity. But 3I Atlas was the complete opposite. The JWST found that its coma was overwhelmingly composed of carbon dioxide, CO2. In fact, there were 8 times more CO2 molecules than water molecules. It was a dry comet in the extreme, the chemical inverse of what we would expect. Scientists, scrambling for an explanation, dove into theoretical chemistry. Could there be some exotic, highly volatile compound at play? One theory that emerged involved something called metal carbonyls. These are compounds where metal atoms, like nickel, are bonded to carbon monoxide molecules. Nickel tetracarbonyl, for example, is extremely volatile and could theoretically be released from the comet's nucleus at very low temperatures, which might explain the nickel signal without iron. But even this theory didn't quite fit. It couldn't fully account for the sheer quantity of nickel observed, nor could it explain the bizarre CO2 to water ratio. The numbers just didn't add up. We were left with 2 deeply unsettling chemical anomalies: an object that was mysteriously rich in nickel but poor in iron, and a coma that was spewing out carbon dioxide instead of water. Taken together, it painted a picture of an object whose chemistry was not forged in the chaotic, messy crucible of a young solar system. This chemistry felt clean, processed. It was the kind of chemical signature you might expect to find not in a chunk of primordial ice and rock, but in something manufactured. The possibility, however remote and unsettling, had to be considered. We were looking at the chemical fingerprint of processed, non-natural materials. It is a profound reminder that we often see the universe through the filter of our own limited experience. We expect comets to be like our comets. But what if the universe has manufacturing processes, both natural and perhaps otherwise, that we haven't even begun to imagine? As if a sun-defying jet and alien chemistry weren't enough, 3I Atlas had another trick up its sleeve, one that added a layer of eerie, almost mechanical precision to its already strange behavior. In astronomy, most natural processes are chaotic and unpredictable. A comet's outburst of gas, for example, is usually a messy, random event, like a geothermal geyser. It happens when a pocket of volatile ice beneath the surface gets heated by the sun and erupts. These events are sporadic and irregular. But 3I Atlas was different. Observations of its brightness and gas output revealed something astonishing. It was fluctuating on a perfectly regular clockwork-like cycle. Every 4 hours, like a cosmic metronome, the object would brighten, release a puff of gas, and then dim again. This wasn't a chaotic flicker. It was a stable, predictable pulse. The signal was so precise and so mechanically stable that it was deeply unsettling. Of course, the first step was to look for natural explanations for this periodicity. The most obvious one is rotation. Perhaps the nucleus of 3I Atlas was a spinning, irregularly shaped object, and the 4-hour cycle was simply its rotation period. On one side of the nucleus, there could be a particularly active geyser or a patch of highly reflective ice. As the object spun, this feature would rotate into view of our telescopes, causing a surge in brightness and gas output, and then rotate out of view, causing it to dim. This is a common phenomenon and a perfectly plausible explanation. Another possibility was a binary system. 3I Atlas might not be a single object, but 2 smaller objects orbiting each other. They could be so close together that our telescopes would only see them as a single point of light. The 4-hour cycle could be their orbital period, with their interactions causing regular releases of gas as they passed each other. This too is a known, if less common, astronomical configuration. But while both of these explanations were possible, there was something about the stability of the signal that didn't sit right. The outbursts of a rotating nucleus are rarely this precise, The active region itself would be evolving, sputtering, and changing as the ice is depleted, which should introduce irregularities into the signal. Similarly, the orbits of a close binary comet system would likely be unstable, decaying over time and subject to chaotic perturbations. The pulse from 3I Atlas, however, was mechanically, unnervingly stable. It was less like a natural geyser, and more like a carefully regulated valve opening and closing. This rhythmic pulsing hinted at something more than just a spinning chunk of rock and ice. It suggested an organized internal structure, a self-regulating mechanism that was controlling the release of gas and energy. This is a feature you would expect to find in an engineered system, a machine, an engine, a probe, not in a random natural object sculpted by the chaos of the cosmos. Think about the difference between the sound of a crackling bonfire and the rhythmic hum of an engine. Both release energy, but one is chaotic and random, while the other is ordered and controlled. 3I Atlas was behaving like the engine. It was this combination of profound anomalies, the impossible physics of the jet, the unnatural chemistry of its coma, and now the clockwork precision of its pulse, that began to shift the conversation in the scientific community. The idea that this might not be a natural object, once a fringe and whispered speculation, was now becoming a legitimate, if terrifying, hypothesis to be considered. What do you think? Does the idea of such mechanical precision in a natural object seem plausible to you? Or does it start to stretch the limits of coincidence? The mystery of 3I Atlas was deepening with every passing day, and with it, a growing sense of urgency. This bizarre object was not going to be in our neighborhood forever. Like all interstellar visitors, it was on a hyperbolic trajectory, destined to swing once around our sun, and then be flung back out into the void, likely never to return. Humanity had one fleeting, fortuitous window to get a closer look, to gather more conclusive data before this enigma vanished into the darkness between the stars. And as cosmic luck would have it, we had two robotic emissaries perfectly positioned to get that closer look. In a stroke of incredible serendipity, two major interplanetary spacecraft, ESA's Hera and NASA's Europa Clipper, were on trajectories that would take them remarkably close to 3I Atlas in late October and early November of 2025. Neither of these missions was designed to study this object. Hera was on its way to study the aftermath of the DART mission's impact on the asteroid Dimorphos, a mission to test planetary defense techniques. Europa Clipper was on a long journey to Jupiter, designed to search for signs of life in the ocean suspected to exist beneath the icy shell of the moon Europa. These were billion-dollar missions with years of planning behind them, their paths meticulously calculated. And yet, by a sheer coincidence of celestial mechanics, their paths were about to intersect with the greatest astronomical mystery of the 21st century. It's important to understand that these were not going to be dedicated, close-range flybys like the Rosetta mission to Comet 67P. The spacecraft would not be able to dramatically alter their courses to get a detailed, up-close look at the object's surface. They would be passing by at a considerable distance, whizzing past at tens of thousands of kilometers per hour. But even from that distance, their instruments were incredibly powerful. Hera and Europa Clipper were equipped with a suite of advanced scientific tools: spectrometers, plasma detectors, magnetometers, and high-resolution cameras. These instruments were far more capable than any ground-based telescope. They could analyze the coma's composition directly, tasting the chemicals it was made of. They could measure the magnetic field and the plasma environment around the object, which could provide crucial clues about the forces driving that impossible sunward jet. They could take images with a resolution far beyond what even the Hubble or JWST could achieve from Earth. This rare, unplanned encounter represented our only chance for what scientists call in situ measurements, gathering data from inside the environment of the object itself. Ground-based observations are like trying to understand a campfire by looking at its smoke from a mile away. A flyby, even a distant one, is like being able to stick your hand in the smoke to feel its heat and smell its chemistry. The pressure on the mission controllers at ESA and NASA was immense. They had to reprogram their spacecraft on the fly, a risky and complex procedure to reorient their instruments and command them to gather as much data as possible during the brief encounter. The next few days became a critical, nail-biting race against time. The entire scientific world held its breath. This fleeting encounter could be the key to everything. The data streamed back from these two probes could either confirm the startling ground-based observations, pushing us closer to an extraordinary conclusion, or reveal them as some grand, complex misinterpretation of a new, but natural, phenomenon. The clock was ticking, and the fate of our understanding of the cosmos was riding on two spacecraft that just happened to be in the right place at the right time. It's a beautiful illustration of how much of discovery is about preparation meeting pure, dumb luck. When you have one anomaly, it's a curiosity. When you have two or three, it's a puzzle. But as the data on 3I Atlas continued to pour in from observatories and spacecraft around the world, the scientific community found itself facing a staggering dossier of at least 15 distinct, documented anomalies. This was no longer just a puzzle. It was a systematic, overwhelming case against a conventional explanation. The object wasn't just breaking one rule of cometary behavior, it was violating the entire rulebook. Let's try to put this into perspective. We've already discussed the three headline-grabbing enigmas: the sunward jet, the 6,000 km plume that defied the laws of solar physics, the skewed chemistry, the bizarre abundance of nickel without its cosmic twin, iron, the rhythmic pulse, the clockwork-like 4-hour cycle of brightness and outgassing. But the list of oddities went much, much deeper. A muted tail structure. Despite the powerful jet and the massive CO2-dominated coma, the classic dust and ion tails that should have been streaming away from the sun were strangely faint and underdeveloped. It was like seeing a massive fire that was producing almost no smoke. An asymmetric coma. The coma itself wasn't a neat spherical halo. It was lopsided and misshapen, in a way that couldn't be explained by solar pressure alone, suggesting multiple oddly directed forces at play. A unique polarization signature. When light reflects off a surface, it becomes polarized. The specific signature of this polarization can tell scientists about the texture and composition of the reflecting material, like the dust in a comet's coma. The light from 3I Atlas' coma had a polarization signature that was unlike any other comet ever studied, indicating that the dust particles it was shedding were of an unusual size, shape, or material. Early outgassing of water. While the coma was overwhelmingly dominated by CO2, traces of water were detected. But they were detected far earlier and at a much greater distance from the sun than the physics of water-ice sublimation would typically allow, suggesting an unusual internal heating mechanism. A conspicuous data delay. This one is more procedural, but it added to the growing sense of intrigue. Key observational data from certain powerful, high-resolution instruments seemed to be experiencing unusual delays in its public release. While this could be due to complex calibration procedures, it fueled speculation and a sense of unease. And the list went on, a cascade of smaller but significant deviations from the norm. The object's trajectory had subtle, non-gravitational accelerations that weren't fully explained by the observed outgassing. Its light curve had strange, intermittent flashes. The ratio of different types of carbon isotopes in its CO2 was slightly off from the solar system standard. Each of these anomalies, taken in isolation, could perhaps be explained away with a new, clever but still natural theory. One could propose a new type of volatile ice, a strange rotational dynamic, or a unique primordial composition. But when you take all 15 oddities together, the problem becomes exponentially harder. You can't just invent one new theory. You'd need to invent 15 separate ad hoc theories that all just happen to apply to the same object at the same time. At a certain point, a simpler, more unifying explanation, no matter how radical, becomes more plausible. The evidence was painting a picture not of a natural object with one or two quirks, but of an object that was fundamentally different from anything we had ever encountered. It was as if we had spent centuries studying sailboats and had just encountered a nuclear submarine. Both travel on water, but the principles governing them are worlds apart. The compiled dossier of anomalies for 3I Atlas was a powerful argument that we were looking at something that didn't belong to the category of comet at all. What category it did belong to was the terrifying and exhilarating question that now hung over all of science. When your existing scientific models are failing this spectacularly, it's time to start thinking outside the box. Way outside the box. As the list of anomalies for 3I Atlas grew, a few brave scientists began to put forward a hypothesis that was once the exclusive domain of science fiction, but was now being discussed in the hushed, serious tones of scientific inquiry. This was the engineered alloy hypothesis. The central idea was this: what if 3I Atlas is not a natural object at all? What if it is, or contains, components of artificial origin? What if it's a piece of extraterrestrial technology? This is an extraordinary claim, the kind that can get a scientist laughed out of a conference. But this radical hypothesis had one powerful thing going for it. It offered a single, unifying framework that could potentially explain many, if not all, of the object's baffling anomalies in one elegant, albeit shocking, stroke. Let's connect the dots. Remember the bizarre chemistry. A strong signal of nickel with a mysterious absence of iron. Where on earth do we find processed, high-purity nickel? It's used extensively in advanced engineering, particularly in the creation of high-strength, corrosion-resistant superalloys. These alloys are critical for technologies that have to withstand extreme environments like jet turbines, nuclear reactors, and most tellingly, spacecraft. Perhaps the nickel wasn't a natural component of a dirty snowball, but the degrading structural material of an ancient probe. Then there was the presence of cyanide compounds, detected in trace amounts but still present. In our own technology, cyanide is a key component in a process called electroplating, which is used to coat materials with a thin layer of metal, like nickel, for durability and protection. The hypothesis suggested that we weren't just seeing the base alloy, but also the byproducts of its advanced manufacturing process. In this scenario, the other anomalies start to click into place. The sunward jet, the most glaring impossibility, could be recontextualized not as a natural plume, but as a directional vent. Perhaps it was a malfunctioning or deliberately programmed release of gas from a propulsion or heat management system. A focused thrust that was powerful enough to counteract the pressure of the solar wind. The clockwork-like 4-hour pulse was no longer a strange rotational quirk, but could be the signature of a regulated mechanical process. It could be a power cycle, a communication attempt, or a system automatically venting excess pressure or heat at precise intervals, just like the pressure relief valve on a boiler. Even the strange CO2-dominated coma made more sense. Carbon dioxide is used as a propellant in some theoretical spacecraft designs and as a coolant in many industrial applications. The outgassing might not be the sublimation of natural ice, but the slow leakage or deliberate venting of onboard materials. The engineered alloy hypothesis was, without a doubt, a speculative leap. It was a theory born of the failure of all other, more conventional explanations. But it was not just a wild guess. It was an attempt to find a single, coherent narrative that could tie together a multitude of seemingly unrelated, bizarre facts. It proposed that the strange physics, the weird chemistry, and the mechanical pulse were not separate mysteries, but different symptoms of the same underlying cause. We were witnessing the slow decay and breakdown of a piece of advanced non-human engineering as it passed through our solar system. While this remains an extraordinary and unproven claim, it provides a chillingly plausible framework. It forces us to confront the possibility that the universe is not only stranger than we imagine, but stranger than we can imagine. What do you think? Is it a bigger leap of faith to believe that 15 separate natural laws were being bent or broken simultaneously, or to believe that we might have finally encountered a piece of technology from another civilization? In any great mystery, it's not just the evidence you have that matters, but also the evidence you should have, but don't. As the global scientific community was laser-focused on 3I Atlas, a new, more unsettling layer was added to the enigma. A conspicuous and unnerving silence from a place that should have had a front-row seat to the spectacle. In early October 2025, before the full scope of its bizarre nature was understood, the trajectory of 3I Atlas took it on a relatively close pass of the planet Mars. This was another stroke of cosmic luck. Mars is one of the most heavily scrutinized planets in our solar system, home to a fleet of sophisticated orbiters from multiple space agencies. Chief among them is NASA's Mars Reconnaissance Orbiter, or MRO. The MRO is equipped with one of the most powerful cameras ever sent into deep space, the High-Resolution Imaging Science Experiment, or HiRISE. This camera is capable of imaging the Martian surface with such stunning detail that it can spot objects as small as a dinner table from its orbit hundreds of kilometers above. As 3I Atlas passed by, the MRO would have had an unparalleled opportunity to capture images of the object from a unique, off-Earth vantage point, potentially resolving its shape, size, and perhaps even surface features, with a clarity that no telescope on Earth could ever hope to match. The astronomical community waited with bated breath for these images. They were a crucial missing piece of the puzzle. The expectation was that NASA would proudly release these historic, high-resolution photos of our second interstellar visitor. But as the days turned into weeks, there was nothing. An official silence descended. The MRO's data stream, which is usually made public on a regular basis, showed a conspicuous gap for the period of the flyby. Now, in the world of space exploration, there can be mundane reasons for such a delay. The data from deep space missions is complex and requires significant processing and calibration before it's ready for public release. The MRO's primary mission is to study Mars, and diverting its instruments to track a fast-moving, unexpected target is a complex operational challenge. The official line, when prodded, was that the data was still being processed and analyzed. But in the context of the 15 other anomalies, this official silence felt different. It felt heavy. It fueled a current of speculation and conspiracy that ran through the scientific underground. What if the delay wasn't mundane? What if the MRO did get the images, and what they showed was so unusual, so unambiguous, so paradigm-shattering, that the space agencies were holding them back? Imagine being the NASA official who first sees that image download from the MRO. What if, instead of a fuzzy, ambiguous comet, the image resolved into something clearly, undeniably artificial? What if you could see structure, angles, glints of metal? The political, social, and existential implications of releasing such an image would be monumental. It would be irresponsible to release it without absolute 100% certainty and a carefully prepared plan. You would need to confirm it, analyze it, and consult with governments at the highest level. From that perspective, a delay isn't just understandable, it's necessary. This absence of crucial data added a new, unsettling element of institutional intrigue to the scientific puzzle. It was no longer just a mystery about a strange rock in space. It was now a mystery entangled with the politics and caution of human institutions. The missing Mars orbiter data served as a powerful reminder that the search for truth is not always a purely scientific endeavor. It can be influenced by human fear, caution, and control. It leaves us with a tantalizing question. Was the silence from Mars a sign of a routine processing delay, or was it the sound of humanity collectively holding its breath before taking a leap into a new and terrifying reality? The universe is a vast and chaotic place, and coincidences happen. But sometimes, a cluster of strange events occurs in such a short period of time that even the most sober-minded scientist can help but wonder if they are somehow connected. As the drama of 3I Atlas was unfolding, a series of other unusual solar system events created a backdrop of cosmic strangeness, raising questions about a potentially larger, more coordinated pattern. Between October 11th and 14th, 2025, just as the anomalies of 3I Atlas were coming into sharp focus, solar observatories like the SOHO spacecraft detected a flurry of activity near the Sun. In the span of just 4 days, 4 separate and distinct objects were observed plunging into the Sun. These are known as sun-grazing comets, or more colloquially, sundivers. Now, sundivers themselves are not incredibly rare. We see them fairly often. They are typically small fragments of comets that have been trapped in decaying orbits, and we watch them vaporize as they make their final, fiery descent into our star. But 4 of them in 4 days is a statistically significant cluster. What made this cluster particularly intriguing was their point of origin in the sky. All 4 objects appeared to be coming from the same general direction, the same direction from which 3I Atlas was making its grand entrance into our solar system. Was this a coincidence? Almost certainly. The leading hypothesis was that these were likely fragments of a much larger, previously unknown comet that had broken apart far from the Sun, and we were just happening to pass through its debris field. But in the charged atmosphere of the 3I Atlas mystery, this explanation felt a little too neat for some. The timing was just too perfect. It was hard not to draw a line, however speculative, between the arrival of the large, bizarre object and the suicidal plunge of 4 smaller ones. It was like seeing a strange ship appear on the horizon at the same time that 4 lifeboats are found washed ashore. They might be unrelated, but the thought of a connection is inescapable. Adding to this pattern of cosmic coincidences was another anomalous event, this one much closer to home. During the live feed of a SpaceX Starship launch, keen-eyed observers spotted an anomalous point of light moving in the background, near the Moon. It was not a known satellite, it wasn't a piece of space debris, and it wasn't an airplane. It moved with a purpose and a speed that defied easy explanation. The footage went viral online, with citizen astronomers and UFO enthusiasts analyzing it frame by frame. Taken individually, each of these events has a likely, if unconfirmed, mundane explanation. The sundivers were probably a fragmented comet. The anomalous light near the Moon was probably an uncatalogued satellite or a trick of the light. But when you view them all together, happening within the same few weeks as the arrival of the most mysterious object in modern history, it creates a powerful narrative of high strangeness. This is a classic example of the human brain's tendency to see patterns, a phenomenon known as apophenia. We are wired to connect the dots, even when no real connection exists. And yet, it serves as a powerful lesson in scientific inquiry. We must be careful not to jump to conclusions and to respect the most likely rational explanation. But we must also remain open to the possibility that sometimes, just sometimes, the dots really do connect. These cosmic coincidences, while likely unrelated, fed the growing narrative that something profound and perhaps coordinated was happening in our little corner of the galaxy. It stretched the canvas of the mystery, suggesting that 3I Atlas might not be a solo actor, but part of a much larger and stranger cosmic play. To truly understand the paradigm-shifting impact of 3I Atlas, we have to place it in the context of a new and exciting chapter in astronomy, the study of interstellar objects. For centuries, everything we studied in the sky, every planet, asteroid, and comet, was a member of our own solar system family. They were all born from the same protoplanetary disk, made of the same stuff, and they all followed the same general rules. But in 2017, that all changed. For the first time, we detected an object, later named Oumuamua, Hawaiian for scout, that was not gravitationally bound to our Sun. Its trajectory proved it came from another star system, a true visitor from the interstellar void. And it was bizarre. Oumuamua was strange for what it lacked. It was a small, dark, elongated object that was accelerating away from the Sun as if it were being gently pushed. This is a classic sign of cometary outgassing. But when we pointed our most powerful telescopes at it, we saw absolutely no coma, no tail, no dust. It was accelerating without any visible means of propulsion. This lack of a coma in an object that was behaving like a comet was a profound mystery that still sparks debate today. Then, 2 years later, in 2019, we found a second interstellar visitor, 2I Borisov. And Borisov was thankfully reassuringly normal. It looked and behaved exactly like a textbook comet from our own solar system. It had a big, beautiful coma and tail, and its composition was familiar. Borisov was a comforting confirmation that comets from other star systems were, by and large, just like ours. It suggested that Oumuamua was the weird one, the outlier. And now we have the third visitor, 3I Atlas. And it is bizarre in a completely new and profound way. If Oumuamua was strange for its lack of a coma, 3I Atlas is bizarre for its reversed cometary activity. It doesn't just have a coma, it has one that is chemically inverted and features a jet that points the wrong way, actively fighting against the forces it should be obeying. This pattern, from Oumuamua's absence of activity to Borisov's normal activity to 3I Atlas's reversed activity, creates what some have called a reversal motif. It seems that when objects from beyond our solar system pay us a visit, they don't just follow our rules, they consistently challenge and even invert our expectations. 2 out of the 3 interstellar objects we have ever studied have been profoundly, fundamentally strange in ways we have never seen before. This forces us to ask a very deep and humbling question. Are our models of what a comet is fundamentally incomplete? Are we like an isolated tribe that has only ever seen wooden canoes, and we are now being visited by a speedboat and a submarine? We call them all boats, but our definition is woefully inadequate to describe what they truly are. This reversal motif suggests 2 possibilities. The first is that the universe is far more diverse and creative in its formation of natural objects than we ever gave it credit for. Perhaps there are entire classes of natural celestial bodies out there. Dry comets, iron-poor asteroids, objects with bizarre internal physics, that are common in other star systems but absent in our own. The second, more provocative possibility is that these objects are not a new class of natural phenomena at all. The fact that they consistently break the rules we've established could be evidence that they are operating under a different set of rules entirely, perhaps the rules of engineering and intent. This pattern of profound strangeness in our interstellar visitors is a powerful wake-up call. It tells us that we cannot be complacent in our understanding of the cosmos. The universe is not just going to send us things we already understand. It is going to send us puzzles, challenges, and perhaps, eventually, revelations that will force us to question the very foundations of what we believe to be true. To appreciate the true magnitude of the intellectual upheaval caused by 3I Atlas, it helps to look at a similar revolution that was happening concurrently in a completely different field of astronomy: cosmology, the study of the origin and evolution of the universe itself. The story of 3I Atlas is not happening in a vacuum. It's part of a broader, thrilling moment in science where our most fundamental models of the cosmos are being challenged and potentially overturned. For decades, the standard model of cosmology has told a clear and consistent story about the birth of the universe. After the Big Bang, matter began to clump together due to gravity. These clumps formed the first stars and eventually grew into vast collections of stars we call galaxies. Within these galaxies, some of the most massive stars collapsed at the end of their lives to form black holes. So the sequence was clear: galaxies first, then black holes. It was a cornerstone of our understanding of cosmic history. But then came the James Webb Space Telescope. With its incredible ability to peer back in time to the dawn of the universe, the JWST started seeing things that shouldn't exist. It was finding ancient, supermassive black holes that were already fully formed in the very earliest galaxies. These black holes were enormous, billions of times the mass of our Sun, and they were far too large to have grown so quickly if they had to wait for a galaxy to form around them first. The timeline didn't work. The observations were contradicting the long-held theory. This crisis in cosmology gave rise to a new, radical, and once fringe theory known as the dark stars theory. This theory flips the old model on its head. It posits that in the very early universe, under conditions of immense density, the first massive objects to form were not stars powered by nuclear fusion, but dark stars. Gargantuan clouds of hydrogen and helium, powered by the annihilation of dark matter at their cores. These dark stars could have grown to immense sizes before collapsing directly into massive black holes. In this model, the black holes came first, and their immense gravity then acted as the seeds around which the first galaxies formed. This is a profound reversal of a fundamental cosmic sequence: not galaxies birthing black holes, but black holes birthing galaxies. This ongoing debate, this potential overturning of one of the most basic tenets of cosmology, provides a critical context for the mystery of 3I Atlas. It shows us that even our most cherished and well-established scientific models are vulnerable. If we can be this wrong about something as fundamental as the formation of the entire universe, is it really so surprising that our understanding of a lesser object like a comet might also be profoundly incomplete? The dark stars debate gives us the intellectual permission to be bold in our thinking about 3I Atlas. It reminds us that science is not a static collection of facts, but a dynamic, evolving process of discovery. When new data contradicts the old map, we can't just ignore the data. We have to redraw the map. The concurrent revolutions happening in both cometary physics and cosmology in 2025 were a signal that we were entering a new era of science, an era where we are being forced to confront the possibility that our maps of reality are missing entire continents of physics. The story of the dark stars is a powerful parallel, a cosmic echo of the lesson being taught by 3I Atlas. Be prepared to have your most basic assumptions about the universe turned completely upside down. The year 2025 wasn't just a landmark year for cosmic mysteries. It was also a turning point for the very tools we use to solve them. For centuries, scientific discovery has been a fundamentally human endeavor, driven by intuition, hypothesis, and the slow, methodical process of human analysis. But we are now at a crossroads where a new partner is joining the quest for knowledge: artificial intelligence. The mystery of 3I Atlas presented a perfect storm of data. There were terabytes of information pouring in from telescopes and spacecraft around the world. Spectrographic data, photometric data, polarimetric data, plasma readings, magnetic field measurements. It was a vast and bewildering dataset, filled with dozens of interconnected anomalies. For a human research team, trying to find the hidden correlations within this mountain of information would be like trying to find a single grain of sand on a beach. It's a task that is simply beyond the scale of the human mind. This is where AI is changing the game. The new generation of AI systems, particularly those based on large language models and deep neural networks, are not just glorified calculators. They are pattern recognition machines of unparalleled power. They can ingest vast, multidimensional datasets and identify subtle correlations, hidden variables, and complex nonlinear relationships that would remain completely invisible to a human analyst. The vast and perplexing dataset from 3I Atlas was a prime candidate for this new form of scientific inquiry. Research teams began feeding all the available data into these powerful AI systems. They didn't ask the AI to test a specific hypothesis. Instead, they gave it a much broader instruction. Find the patterns. Tell us what's connected. The potential of this approach was revolutionary. An AI could, for example, discover a hidden mathematical relationship between the 4-hour pulse cycle and the fluctuating emissions of nickel atoms. It could find a correlation between the unique polarization of the dust and the strange asymmetry of the coma. It could identify that the sunward jet's intensity seemed to be linked to subtle changes in the solar wind that were too small for humans to have noticed. In this new paradigm, AI is evolving from a mere tool, like a calculator or a microscope, into a true partner in the process of scientific discovery. It acts as an intuition amplifier, pointing human scientists toward avenues of investigation they never would have considered. The AI might not provide the final answer, but it can uncover the hidden signposts that lead to the solution, revealing the underlying physics that connects all the seemingly disparate anomalies of 3I Atlas. This moment in 2025 marks a fundamental change in how we do science. The lone genius, having a eureka moment in the bath, is being replaced by a new kind of collaborative team. A human scientist with their creativity and contextual understanding working in tandem with an AI with its inhuman ability to process complexity. The mystery of 3I Atlas is not just a test of our understanding of physics, it is also a showcase for this new technological frontier. It demonstrates how our ability to solve the great cosmic mysteries is about to take a quantum leap forward, powered by a form of intelligence that is in its own way as alien as the object it is trying to understand. While astronomers were looking up at the heavens in bewilderment, another group of scientists was looking down at the strange and wonderful world of the very small, and making a breakthrough that would be just as profound. In 2025, physicists achieved a stunning milestone in the field of quantum mechanics. They successfully teleported quantum information across 56 kilometers of existing commercial fiber optic cable. Let's be clear about what this means. This isn't the beam me up, Scotty teleportation of science fiction, where a physical object is dematerialized and rematerialized somewhere else. This is the teleportation of information. It involves using the bizarre principles of quantum entanglement, what Einstein famously called spooky action at a distance, to transfer the exact quantum state of a particle from one location to another without that information ever crossing the physical space in between. A particle at one end of the 56-kilometer cable would instantaneously adopt the properties of a particle at the other end. For decades, this had been a spooky theoretical concept, a mind-bending quirk of quantum math that happened in pristine laboratory conditions over very short distances. But the breakthrough in 2025 turned this laboratory curiosity into a practical, real-world reality. Using the noisy, imperfect fiber optic cables that form the backbone of our internet, they had shown that the spooky rules of the quantum world could be harnessed and controlled on a citywide scale. This growing mastery over the fundamental laws of physics provides a provocative, if highly speculative, parallel to the mystery of 3I Atlas. It serves as a powerful reminder that there are realms of physics that we are only just beginning to understand, realms where our classical, everyday intuition about cause and effect completely breaks down. Could the impossible behavior of 3I Atlas be governed by some large-scale quantum phenomenon that we don't yet understand? This is a huge speculative leap, but it's one that the strangeness of the object almost invites us to consider. What if the sunward jet isn't a physical plume of material in the classical sense, but some kind of quantum projection or energy transfer? What if the object's state is somehow entangled with the sun itself, leading to its bizarre, counterintuitive behavior? Perhaps the very act of our observation is influencing its state. In quantum mechanics, the observer is not a passive bystander. The act of measuring a quantum system can fundamentally change its properties. Could our intense focus, our barrage of radar, lasers, and telescopes be affecting this object in a way that our current physics cannot explain? This is, of course, wild speculation. But the quantum teleportation breakthrough is a crucial piece of the intellectual landscape of 2025. It shows that the universe operates on a set of rules that are far stranger and more magical than our everyday experience would suggest. It invites us to be open to the possibility that the solution to the three-eye atlas mystery might not be found in the familiar world of classical mechanics, but in the spooky, interconnected, and deeply mysterious world of quantum physics. Just as we are learning to teleport information across cities, perhaps the universe has already mastered principles of physics that allow for feats we currently deem impossible. As if the year 2025 wasn't already packed with enough scientific revolutions, another long-held dream of humanity was finally being realized. This one with the potential to fundamentally reshape our civilization. After decades of tantalizing promises and frustrating setbacks, 2025 became the year that humanity finally achieved repeatable, scalable, and commercially viable nuclear fusion. This wasn't just another laboratory experiment producing a brief flicker of energy. This was the ignition of the first generation of power plants that could sustainably generate more energy than they consumed, marking a point of no return in the quest for limitless clean energy. Nuclear fusion is the power source of the stars. It's the process that makes the sun shine. It involves taking light elements, like isotopes of hydrogen, and forcing them together under immense heat and pressure until they fuse into a heavier element, like helium, releasing a tremendous amount of energy in the process. For over 70 years, it has been the holy grail of energy research, a way to generate power with no carbon emissions, no long-lived radioactive waste, and a virtually inexhaustible fuel source found in seawater. Achieving this milestone was not just an engineering triumph. It was a profound victory in our understanding and mastery of the fundamental forces of the universe. We had, in a very real sense, built a miniature star on Earth. This breakthrough provides a powerful and inspiring parallel to the challenge presented by Three-Eye Atlas. Just as the achievement of fusion is fundamentally rewriting the laws of energy production and economics on Earth, the enigma of Three-Eye Atlas is forcing a rewrite of the laws governing celestial bodies in space. Both breakthroughs, one happening in a reactor on Earth and the other in the cold vacuum of space, are signals that we are entering a new era, an era where previously theoretical or impossible physics is becoming tangible and real. The successful harnessing of fusion power is a testament to human ingenuity, perseverance, and our ability to solve seemingly insurmountable problems. It tells us that the laws of physics are not just things to be observed, but things to be understood, harnessed, and used to build a better future. It gives us a sense of hope and capability as we face the cosmic mystery of Three-Eye Atlas. If we can build a star on Earth, then surely we can solve the riddle of a strange visitor from another star. These two parallel breakthroughs, fusion and the Three-Eye Atlas anomaly, compel a radical reassessment of what we believe to be possible. On one hand, we are finally mastering the physics that powers the universe. On the other hand, the universe is showing us that it operates on principles that we don't even begin to understand. It is a moment of supreme confidence and supreme humility, all at once. It is a message that the 21st century will be defined by our ability to both harness the known laws of the universe and our courage to confront the evidence of laws that are as of yet completely unknown. And so we arrive at the heart of the matter. When we step back and look at the full picture of the year 2025, we see a story that is much bigger than just one strange comet. On one side, we have the profound anomalies of Three-Eye Atlas, an object that breaks the laws of physics, exhibits an unnatural chemistry, and pulses with a clockwork-like precision. On the other side, we have a cascade of paradigm-shifting breakthroughs on Earth, the dawn of practical AI-driven discovery, the mastery of quantum teleportation, and the harnessing of limitless fusion energy. Taken together, This convergence of cosmic mystery and technological triumph suggests that 2025 marks the dawn of a new scientific revolution, as profound as the one started by Copernicus or Einstein. The central question that emerges from this incredible year is this: are we entering a decade where anomalies are no longer seen as errors in our data, but as powerful signals that our scientific models are fundamentally and deeply incomplete? 3-Eye Atlas is the ultimate challenge to our comfortable categories. We call it a comet because it has a coma, but it behaves like nothing we've ever seen. It challenges us to consider that the universe is far stranger, more complex, and more creative than our limited classifications allow. It forces us to confront the humbling possibility that our meticulously constructed maps of reality might be missing entire continents of physics, biology, and perhaps even technology. This story, the story of 3-Eye Atlas, is not just about astronomy. It is about the nature of discovery itself. It holds a powerful lesson that we can all apply to our daily lives. How often do we encounter an anomaly in our own life? A person who doesn't fit our stereotypes, an event that contradicts our worldview, a feeling that doesn't match our expectations. And our first instinct is to dismiss it as an error. We say, "That can't be right," or "They must be mistaken." The lesson of 3-Eye Atlas is to do the opposite. It teaches us to cherish the anomalies, to lean into the data that makes us uncomfortable, to have the courage to say, "My model of the world may be wrong," because it is in those moments of profound uncertainty, in those encounters with the truly unexpected, that real growth and learning occur. Whether you're a scientist studying the stars or simply a person trying to navigate the complexities of life, the path to wisdom is paved with the courage to question your own assumptions. The universe is under no obligation to make sense to us. It is our job to expand our minds to encompass its vastness and its strangeness. Perhaps 3-Eye Atlas is a natural object, a member of a new and bizarre class of celestial bodies that will teach us more about the formation of star systems. Or perhaps it is something else, a relic of a technology so advanced that it appears to us like magic. Either way, the answer will change everything. We stand on the verge of a new era of discovery, armed with new tools like AI and a renewed sense of humility and wonder. The journey to understand this enigma is just beginning, and it is a journey that we all get to take together. So what do you think? After hearing all the evidence, does your intuition tell you that 3-Eye Atlas is a profound natural mystery, or the first tantalizing sign of something more? Let me know your thoughts in the comments below. Thank you so much for joining me on this incredible journey to the edge of the known universe. I hope it has sparked your curiosity and left you with a sense of wonder. Take care of yourselves, stay curious, and I wish you all the very best of health. If you enjoyed this deep dive, please consider subscribing to the channel for more stories that explore the biggest questions in science and what they mean for us. I'll see you in the next one.